Hello, I'm Michael,
And I'm Andy.
and this is our chemistry project.
So what we have here is we have magnesium and nitric acid, and we will be converting it into magnesium nitrate and hydrogen, or since it's H2 form, it would be hydrogen gas. So
First step we have to do is balance the equation.
equation, yeah.
Equation, yeah.
So as we see here, we have magnesium,
On the left side.
hydrogen, nitrogen, and oxygen. And on the right side we have the same thing, yeah. Hydrogen, nitrogen, and oxygen. So here we have hydrogen here, and if we're looking on this side, there's two hydrogens there, so we know right off the bat this probably is a 2. So we can test that, and if it doesn't work then we'll try again, but let's try that. So that'd be 2 hydrogens, 2 nitrogens, and total of 6 oxygens. Magnesium, well, nitrogen, as we saw, is 2 there, so it would also have 2 here, so that would be, again, 2, so you would have 2 magnesiums, 2 nitrogen, and 6 oxygen, so that's balanced. Next we have the H2, which is 2 hydrogens, so that'd be one of these, since that is H2, and magnesium, there's 2 of them, so we would put a 2, and that is how you balance the equation. Oh, wait a second. Forgot those are 2 there. That's how you do it. And just erase that really fast. There we go. Get that.
Okay, I am Jack, and this is my portion. So we're gonna balance this equation if we have 40 grams of magnesium. So we're gonna do our crossroads just like in class. So we're gonna start off like this. And so obviously we start off with 40 grams of magnesium on the top in the first corner. Then we have 24.305 grams, because that's the atomic weight of magnesium. And we have 1 mole on top because we're converting into moles. Now on the next portion, because we're going from magnesium to hydrogen, we need to put H2 on top and 2 moles of magnesium on the bottom. Then on the next portion, because we're going to have to have 1 H2 on the bottom, because we're going to go out of, because these are moles, and we're going to have to go into the atomic number, which is, or the grams, of 2 nitrogen, which is 2.016 grams of nitrogen. And under this goes the mole of H2. And if we do this math, it should equal, because we'll divide 40 by 24.305. Or we can start off at the top, which is 40 times 2.016. And then divide by 24.305 times 2, which would equal 1.66. 1.66 grams of hydrogen. For the next part, it cannot be 1.66, it has to be 1.7 for it to work.
I'm David, and now we're going to do the percentage yield for how much hydrogen gas has been made. This is a hypothetical percent yield, which we're going to do. Okay, so let's say someone did the experiment and they got 1.7 grams of hydrogen gas. So, immediately looking at it, they have a good yield of hydrogen gas, but we're just gonna show how to do the percent yield anyway. So the way you do it is you put 1.7 on top, 1.7 on the bottom. Top part being how much they got, the bottom part being how much with hydrogen should have gotten it in a perfect situation, which is 1, and then run that by 100 to get the percentage. 1 times 100 obviously being 100% yield. So this is a hypothetical perfect situation in which they get 100% the average yield. Now, erasing that.